Hello, namaste, adab everyone. Hello everyone, and welcome to my YouTube channel. I'm Saket, and today I'm excited to share with you the details of an amazing project I have been working on as a code developer. It's an innovative writing application that aims to revolutionize the way we travel and communicate. So, what exactly is this writing application all about? Well, imagine having a convenient and efficient way to get around town where it's for your daily commute, running around, or simplifying exploring new places. This application provides a seamless platform that connects riders with various transport options, making it easier than every ever to get from point A to point B. One of the key features of this application is this user-friendly interface. We have designed it for intuitive and easy to navigate, ensuring that riders of all ages and tech savviness can use it effortlessly. With just a few taps on our smartphone, you can access a wide range variety of transportation services including taxis, bikes, autos, auto rickshaws, lorries, etc. But what sets this riding application apart from other? Well, we have put strong emphasis on safety and reliability. We understand what we understand that when it comes to transportation, these factors are at most important. That's why we have implemented a digital screening process of our drivers and pattern we trusted. Additionally, we have integrated advanced mapping and routing technologies into this application. This means that you all always have access to the most efficient and optimized routes, saving your time and minimizing any potential delays. We have also introduced a real-time updates that you can stay informed about traffic conditions, estimated arrival times, and other related information. Now let's talk about the benefits of using this riding application. First, foremost, it offers convenience. No more waiting on the street corners or struggling to find a parking spot. With this application, you can easily request a ride from the comfort of your own home or office, or drivers will arrive at your location prominently. Secondly, this application promotes sustainability by encouraging the use of sharing transport options like ride shares and bikes. We are helping to reduce traffic and lower carbon emission. It's a win situation for both riders and the environment. Lastly, this ride application is all about enhancing your overall travel experience. We have taken into account and feedbacks and performances of users to create a platform that creates to their needs. Whether you are looking for a budget friendly option or a luxurious ride or a specific vehicle type of this application has got you covered. So there you have a brief overview of our writing application project. I hope you found this introduction informative and exciting. Stay tuned for more videos on my channel. Uh, Now we are we are going into the deep into this topic. What we have learned, there is a two applications Ola and Uber. Why we should use Rider? To, there's a five key points to why to use Rider. It is a multimodal transportation. Enable users to seamlessly switch between different modes of transportation within the app. For example, they can start the journey with a ride share, then switch the bike or scooter for the last mile. This feature provides flexibility and convenience for the user. And in the second point, we are going to listen that in app payment integration integrates a secure and user-friendly payment system with the app. This allows riders to pay for the trips directly through the application, eliminating the need for cash transactions for ensuring a smooth, hassle-free experience. And the third point in this, we are going to learn that ride sharing and carpooling. Implement a ride sharing and carpooling feature that matches riders heading in the same direction. This not only helps reduce traffic congestion but also provides a cost effective option for users who are willing to share the rides with others. And in the fourth point, we are going to explain that real time safety features. Incorporate real-time safety features such as live tracking, emergency assistant, and driver's rating system. These features enhance the overall safety and the peace of mind for both riders and drivers, ensuring a secure and reliable experience. In the point number 5, we'll be learning about the personalized recommendations. Utilize machine learning algorithm to provide personalized recommendations to users based on their performances, previous rides, and the location history. The feature can suggest the most suitable transportation options, routes, and even nearby points on interest, making each ride a tailored experience. By incorporation these features into the riding application, we can create a comprehensive and user-centric platform that other convenience, safety, sustainability, and an enhanced travel experience for all users. So, to create this riding application, we have used priority queue and the cost efficient algorithm and Dijkstra's algorithm. What is meant by priority queue? Priority queue is a queue in which the person who is having a more priority is the given first place. So here is the code for the priority queue. Uh, Before going into the code, I'll be explaining you the theory of how the priority queue works. So I'm going into my paint. I've been open my paint, and let's start to understand the priority queue. So first I've been drawing two boxes. So one more, and I'm going to take one more box. I'm little bit increasing this screen. Don't worry, guys. Never mind about my drawings. It's little bit clumsy. Okay. The first one is the user one, and the second one is writer. Okay. So whenever a person is added into the uh, queue, then the person is added back, and the person is been exited from the first. So when we book any ride, will be added at the end, and the person who has booked his ride in the previous will be exited first. So a user is having a priority 7, let's think, and a rider is having the priority 8. Let's consider the second rider is having a priority 6, and the third rider up with priority 5, and the second user with the priority 6, and the second user with priority 5. So now let's understand the priority queue. A person having with a high priority will be getting the right. So what our application does when when we book the ride, our application first picks the higher priority one. This is connected with this, and this is connected with this, and this is connected with this, and this is connected with this. Okay, so this 7 and this 8 connects together and makes a right. Gets the right. Okay, so I hope you understand the priority queue. The priority queue is nothing but where the person is having a high priority and where the rider is and high getting the high priority. They both will combine together and will successfully get a ride. How the rider is getting the higher priority and how the person is getting the higher priority. There's nothing but the rider gets the higher priority by his ratings, by the last journey, and by the completion of his journey. How fast he completes the journey, the higher priority he gets. And the user gets the priority on the distance, on the location, on the shortest location, or the uh, nearest point, or the connect or the rider where the person is standing. If the rider is nearby, then that person gets higher priority and will be getting the ride easily. So let's get into the uh, code. 1 minute, guys. Where is it? Yeah, let's get deep into the this. Okay, this is this C code which have been implemented. This is the entire code. I'll be explaining in a short way where you can understand it. Uh, C. Here, the priority. Priority is nothing but I've been said in the old video in the last clip. It is where the person gets higher priority, the person will be getting the first right. Uh, I'll be explaining one more topic, guys. Please stay line. NQ and DQ. NQ and DQ is nothing but NQ means the person lifting or the person getting the ride. DQ means the person who ordered now the vehicle will be added back. Adding back is called DQ and going from the front is called NQ. That's all, guys. And here, user 1 having 1 with a priority 3, and driver is having his id is 1 or 2 and having the priority 5. And in user 2, the person is having uh, is his id is 2 and is having priority 5, and driver is id is 105 and is having priority 1. So guys, I think you have guessed the answer. The person uh, in which who is having the priority 3 will be the first, and the driver who's having the priority 5 will be getting the rider to take the ride. Yeah, I think you have been got this. See here, allocated id is 2 and priority 5. This person gets the ride because he's having a higher priority 5, and the rider with 10 id 102 and priority 5 will be getting the vehicle because he's having the priority 5. And where here the user is having priority 3 and here the driver is having the priority q 5. By this, both are having the higher priorities, so they both matches together by having a higher priority, and they'll be getting the right. In this way, this priority queue helps in the application, Ola application, or in the Uber application, and as well as in our Rido application, through which the riders will be getting the right by this algorithm. We'll be getting, we'll be going into the next uh, as program or the algorithm. It is cost calculation. Cost calculation is nothing but when we get into any drive or anything, there will be a cost or a fare for our travel. So a little fare per kilometers or per miles, there will be a some fixed price fixed by the application. So in our application, the fixed price per kilometer is 10 rupees. Okay, guys, our application has fixed 10 rupees 10 per kilometer. So here it is a float. means the amount can be in what we say, it can be in paisa or it can be in rupees. So we have been used float for the calculation of the amount. In this instrument, float will be the distance and float will be the cost. The distance can be in 2.5 something and the float cost will be 1.6 something, whatever it may be. But there will be a point some value. So we are using float here. Printf we'll be asking the rider how many kilometers the person has been traveled. So the rider will be giving some particular value around 20 kilometers. So our app will print the value and it will calculate the distance and it will calculate the cost and it will display the value to the driver. Then the driver will be showing the amount to the customer and the customer will be paying the amount to us with a hassle-free payment. Then the customer can pay directly the amount to uh, application through his app. There is no need. There will be no what we say. There will be no connecting of cash between the customer and the rider. It will be the direct connection between the application and the user, so that the driver cannot be cheat the customers. This is the thing which we added in our application. So we'll run this code. So okay, I think we have traveled 23 kilometers, let's think, or else let's think we traveled 12 kilometers. Okay, I'm pressing here 12, 1, 2. I'm pressing enter. See, here is 120 kilometers. What, how we get 120 kilometers? Here is 10 rupees, which is fixed by our company. Per kilometer is 10. So the rider has been traveled 12 kilometers. So for 12 kilometers, it will be multiplied into 10 and we will be getting 120 rupees. So 120 rupees will be paid by the customer to the application. So then there will be no connection between the customer and the user. I've been said in the previous words. This is the thing, and this is how the cost affection works here. In the next code, we'll be deep dive into the Dijkstra's algorithm. Dijkstra's algorithm is nothing but a location. Okay, I'll explain you in this by the paint. You can get everything. You can understand it. So 1 minute, I'm erasing this. Okay. So now we are into a new file. Here I'm going to explain about the Dijkstra's algorithm. So here is one point, and here is one location, and here is one location, and here is one location, and here is one location. So let's connect these locations. One, two, three, four, five, six. A, B, C, D, E, 5, 6, 7, 8, 9, 1. So the main motive of this Digitas algorithm is to find the distance from A to C, A to B, and B to D, and D to E, and E to C. So, if we travel from a distance A to B, we don't know the actual distance or the actual kilometers or the actual price. In the past, I've been said we can calculate the amount based on the kilometers. The kilometers will be calculated by this Dixer's algorithm. This Dixer algorithm will play a main role in this riding application. The main motive of this is to calculate from A to C. The A to C is having a value of 5, and if a person is traveling from, let's think you are a traveler, okay, so you want to go to from Chandigarh to Delhi. So this is from Chandigarh to Delhi. So you are going on a work from Chandigarh to Delhi, and again you want to return from Delhi to Chandigarh. Okay, you want to go from Delhi to Chandigarh and Chandigarh to Delhi. So in this situation, we need this Dixer's algorithm because to calculate the entire kilometers based on a fixed price. So now from Chandigarh to Delhi, it's five rupees, or let's think value is 5. Next, the person again return back from Delhi to Chandigarh plus 5. Again, the person wanted to go from Chandigarh to Uttarakhand plus 9. The total value will be 90. So this total kilometers we cannot calculate in a single, we cannot calculate according to the application. So with this, we can calculate the distance traveled by the customer and the distance traveled by the user and the number of kilometers traveled, the cost value, and the places they have been reached, which place they have been reached first, and for which place they have been went next. We can get to know in this Dixer's algorithm. Dixer's algorithm also helps in connecting the ways. See, from C to E, from E to D, and D to C. They are having some connections. C to E is a place where C connects E, and these two places are connected to each other. And E to D, these two places are connected with, think these are kilometers, connected by 7 kilometers. Okay. Now D to C, it's connected around 8 kilometers. So now B, if B want to if A want to travel from A to D, let's suppose. So A should travel from A to C, uh, A to C. Let's change the color. If A want to travel to D, so A should go to C, then D, or else A to C, C to E, then E to D. In this way, it should go. By this Diksha's algorithm, we can mainly understand the distances, how the places are connected, how the person can reach the places easily. See, now A want to reach D, so 5, 8. So 8 plus 5, 13. Now this is equals to a. Same this if it travels this all 5, 6, 11, and 11 plus 7, total 15. Okay, see, if it travels directly, he'll be getting 13 kilometers. If it travels by the connected, he'll be getting 15 kilometers. The main motive is where the person can go and reach his location in a fastest way. The zigzag algorithm helps the uh, rider, or the rider gives him the fastest way to drop the client in his location in the fast. So this zigzag algorithm's main motive is that he can drop the client in his location in a fast hour. So this is how our code works. See, this is the total code which we have run. See, according to the characters, the code runs. This is how the cost efficient. This is how. The problem statement is inefficient driver passenger matching. Existing ride sharing platforms often struggle with efficient matching drivers with passenger, result in increased waiting times, longer routes, and suboptimal resources utilization. And we have been designing this entire thing for to give a safest ride to any girls or any people who are getting travel, or who are getting the ride from our rider app. We should provide them safety and safe payments. Everything should be safe, hassle free. So where the people trust, where people get trust on us, and we'll be building trust in them. The only thing I wanted to say is use Rido, get the safest ride, hassle free payments. So this is what I've been developed, and my team members has been developed this code and the entire thing. Uh, that's all. Thank you for the day. Let's meet in our second video. Till that time, please subscribe to my YouTube channel, like, share. Thank you. Bye bye.